5, and today we are actually going to do part 2 of lesson 29. So I guess you could call it lesson 30. I'll wait for 1 minute to let folks jump on, and we're going to continue from where we left off yesterday, talking about these understanding two-way frequency tables, which I believe are a excellent topic to get some points on the end of year exam, because a lot of classrooms don't get very deep into the statistics and probability portion of the curriculum, because it's right at the end of the year and people are starting to wrap up and get ready for doing review for the EOC. So a lot of times at the end of the year, this actually ends up being it ends up being underutilized or undercovered at the end of the year, this statistics stuff. So this should be a good topic to go over. So let me review. We started this problem and then we had a little bit of a challenge with the stream, so I decided we'd call it a day and start again today. So Carl here asked the students in his high school what activity they like to do in gym class. The results are shown in the table below, and it wanted us to construct a two-way frequency table to display this data. Okay, Carl wants to recommend that the gym class is separated by gender and that students participate in different activities based on their gender. So what do you think? Does he have the data to support this proposal? Would this be a very good idea to do to begin with? Is, I think, another question. But we just want to see what the data would show to see if it even makes sense logically. So we already counted up our hash marks here to show what the final count of these tallies were for the females, with how many females wanted basketball. There'd be 23, 32 females wanted volleyball, 16 females wanted softball, 18 females wanted track, 30 males wanted basketball, 26 males wanted volleyball, 12 males wanted softball, and 21 males wanted track. So we put those in that same spot. You also could have made your own table as well, just lining up the data in a new table. Now, if we were to look at the totals, let's go ahead and review what this might look like if we move over to the calculator here and add those columns and rows up. So 23 plus 32 plus 16 plus 18. So we have a total of 89 females. And add these up: 30 plus 26 plus 12 plus 21. And looks like we have 89 males as well. Now, just for fun, let's go ahead and add horizontally to see what the totals of how many total want to play basketball. So that would be 23 and 30, so you can see what I'm adding. So that gives us 53. $32 and 26 for males and females that like volleyball. 16 and 12. How many like softball? And 18 plus 21 is how many total people like track, is 39. Okay, so what do you think the total if we add these up? If you recall from yesterday, the total if we add these vertically should equal the total if we add the totals horizontally, and that's the total amount of people that were in the survey. So let's try that. 53 plus 58 plus 28 plus 39, and that gives us 178. Let's see if we added 89 and 89, if we also get 178. So we do also get 178. So we can see that there's a total of 178 people that we verified adding two different ways. So looking back, let's look at where our question was again. So Carl recommended that the gym class be separated by gender and that the students participate in different activities based on their gender. So I suppose what he was probably thinking, as well as friends, that maybe his friends and him, they don't like to play volleyball or softball or track. They just want to play basketball all the time. And his qualitative, not quantitative, theory at the beginning of this study was that, well, all the males just want to play basketball only. And we're going to see if that qualitative hypothesis that he probably had matches up with a quantitative reasoning to justify that that goal that he set out to do. So you could do it like this. Here's another picture of a little bit of a cleaner table, if you like to look at it that way. Okay. The next thing we're going to do, in fact, maybe I'll leave it up so you can see, you can observe either one. Okay, so they already found the totals for the vertical, for the columns there. Now let's look at the percents. So what are the percentage of females that like basketball? So to do this, I'm going to do 23 out of 89. So that gives us 26%. Now let's do 32 out of 89. 36%. 16 out of 89. 18%. 18 out of 89. 20%. And if you do the total over itself, then this is going to be 100%, right? Because if you add up all of the percents together, you're going to get 100%. So 100% of the students that participated were accounted for in this case, okay? So let's do the same thing with the males here. 30 out of 89, also 89. There just so happens to be the same amount of males and females in this study, so don't let that confuse you. Just a coincidence. So 34%, 26 out of 89, 29%, 12 out of 89, 13%, 21 out of 89, 24%. So what did we find? So we want to find the percent of, here's giving us the hint down here, find the percent of the females who chose each activity, and do the same for males when we round to the nearest whole percent. We just did that. And what if we were just to quickly identify the most popular sport survey for each gender? So 26, 36, 18, 20. 36 for the females is the most popular. So certainly more than a third, but it's still not an overwhelming majority. It's not like more than half chose volleyball. Let's look over at the males. It's even less decisive that the most popularly voted for sport among the males was 34%. So it's certainly, I would say so far, does not justify separating the males and females. In fact, it doesn't even necessarily justify picking a single sport. There's a pretty good distribution. Looking down here at softball, that was the sport that both genders ranked there's the fewest votes for. So if anything, there might be an argument for maybe we spend a little bit less time on softball, or if it came down to budgets, if there was someone that thought it would be a good idea to upgrade the softball equipment, well, maybe it could be argued that maybe we can hold off on the softball equipment because most of the students choose other sports over softball. But going back up here, do you find any data here that supports his proposal? His proposal again wants to recommend that the gym class is separated by gender and that students participate in different activities based on gender. I don't think so, right? It's a pretty level split. If there was maybe more than half that had chosen a single sport, that maybe could be a threshold that would warrant a conversation that we think about it. But this is a pretty even split down each of the 4 sports in both genders. So I would say it's probably not a strong justification to do so. Let's see what the book's proposal was. This is saying Carl could not use this data to support his proposal because there's no significant difference in the results. So we agree there. So go ahead and post any questions you have. I'm going to leave this example 5 up for just a moment. And I strongly encourage you to give number 5 a try. And I'll even leave the hint up there as well. So I will take a short pause to let you think of example 5. Okay. So what do we think? Let's do number 5 together now. So in a group of 180 students, 110 are in the drama club, 80 are in the computer club, and 15 are in both clubs. Make a two-way frequency table and look for possible association between the variables. Okay, so this can be a little bit tricky because if we look at this, there's only 2 classes, right? In previous examples, so in the past examples, we had like So we had male, female, so we had subcategories of maybe three sports, right? There's the football, baseball. We'll just leave it at the 2. So if we broke it down by baseball and football, and male and female. So this is how we were breaking down these frequency tables before. Now this can be a little bit tricky because in this situation here, there's drama club and computer club. It's not asking us to break down males and females in drama club or computer club. What it's saying is that there's drama club and there's computer club. Out of 180 students, there's a certain amount that are in drama club and a certain amount that are in computer club, and probably a certain amount that are in neither. So this takes a little bit more logic, and it's fun too. There's a creates a little bit of a puzzle out of it, but here's what it ends up looking like. If you only have essentially two items that we're looking at, drama club and computer club, then this is what it's going to look like. So you're going to put computer club for the headers of maybe the columns, and drama club for the headers in the rows. So here's what it might look like. So computer club, drama club, what's next? So now we've only made one cell, right, with a computer club and drama club. So this is the trickiest part, I think, is to just set this up. And part of the tricky part of establishing what these headers are going to be on the rows and columns is because it doesn't really explicitly tell you what this next category is going to be. But if there's just two categories that we're looking at, here's what you want to think about. You want to put one to start off your headers up top, and the other to set up your headers on the side. And this is what this other heading is going to look like. So in computer club, not in computer club. So if this is drama club, then the cousin over here would be not in drama club, and it's going to make sense in just a minute. Okay, now let's go ahead and make the space for the totals. So this over here is going to be the total for drama club. Okay, and how we would read that then is, so there's a certain number of kids that are in drama club and computer club. There's a certain number of students in drama club, but they're not in computer club, they're just in drama club. And if you add those two up, the ones that are taking the drama and computer club and the ones that are taking only drama club, if you add those up, that would be the total number of students in drama club. And it tells us up here that there's a 110 in drama club. So this is another part that's maybe a little bit confusing to start, is where to put that total, because it'd be very easy after we made this heading to put the 110 here, perhaps. or in one of these cells, but it's really talking about a total of 110 kids in drama club. Some of them are only in drama club. Some of them are in drama club and computer club. So let's see if we can put this 80 in the right spot. So there are 80 in the computer club. So now we're going to look at the column. Okay. So should we put that 80 here? Or should we put it here? Or is that the total? If you said total, that would be correct answer. Maybe I'll even do like, make this line a little bit bolder to separate the totals. Okay, so a total number of 80 students in computer club. Okay, and of those 80, there's going to be a subset of those that are in computer club and drama club. Then there's going to be a set that are in computer club but not in drama club, that they're only in computer club. So is there any other data that we can use? Because as this stands, because we know that this cell plus this cell is going to add up to get to this cell. We know that this cell plus this cell will add up to the total on this cell. So on any column or row, we can only have one unknown cell that we're going to either use addition or subtraction from the total to find that one unknown cell. So as it stands here, this would be impossible to solve, impossible to fill in the rest of this table. So luckily we have a little bit more information. So it says, and 15 are in both clubs, okay? So both clubs would be this cell here saying that they are in computer club, and that column means this row that they're in drama club. So looking at this cell, this means they're in computer club and drama club. That would be 15. So maybe it would help to even put tiny labels in the cells here. So this cell would be both. You don't have to do this, but it might help to visualize kind of what's happening, right? Because this is the intersection, and you can think of it like maybe crosshairs or making an intersection or whatever, or if you drop down from computer club and go across from drama club. So those would be kids in computer club and drama club. So where does that intersection happen? Well, it happens over that cell. So that would be both. Okay, so what's the opposite of both? That would be neither, right? So that would be where not in computer club meets also kids that are not in drama club. They're not in either club. So the neither cell would be where those two pens cross now. So I'll say neither. Okay, so which one would this one be? So this would be at the intersection of in drama club, but not in computer club. So we would say drama only. And again, you don't have to label these like this. I'm just doing it to hopefully help picture what's happening. So where does computer club and not in drama club? So that cell would be computer only. All right. So do you remember how we were talking, if looking at any of these rows or columns, if you had only a single unknown cell, we could use addition or subtraction to figure out what the unknown cell was. So 15 plus, and maybe we'll do a different color. So we'll leave the blue as the ones that they explicitly gave us at the beginning, and let's see how many we can figure out. So 15 plus x gets us to 110. So this is going to be 110 take away, how many are in that cell? 15. Gives us 95. So what else could we start to figure out? Now at this point we're stuck because we really need, no, we could go a little bit further. We could figure out this one. But I just realized there's a little bit more information, right? Because we filled in the 110 here of all of Drama Club, and we filled in the 80 here of all of the students in Computer Club. We filled in the 15 that are in both. We did that. But now it's telling us that it's a group of 180 students, right? So this is going to be the total number of students surveyed right down here. Right? Because what this is an intersection of, if we add this of all of the students in Drama Club, but not in Computer Club, then we would get to, we're going to get to 180. And then over here, if we add up all of the students that add up to the total students taking Computer Club and not in Computer Club, then that's going to add up to 180 as well. So now we can start to work around this board any way we like. We could do 80 minus 15 to find this cell, right? Because 15 plus blank makes 80. So I can do 80 take away 15 to find blank, 65. Any other columns or rows where we're only missing one? So how about this one? So 80 plus blank gives us 180. So 180 take away 80 is 100. Okay. Now we could find this one. So we could find the students that are surveyed in this school, but are in neither club. So we would do 100, take away 95 to get blank, and that would be 5 students. Now this one, 110 plus blank makes 180. So 180 take away 110 would be 70. Right? 110 plus 70 makes 180. So now we've filled in this entire table, and this is, it was pretty easy. The most difficult part, I think, is the very beginning, because it's very how most students start. If they only have these two categories, they would write here Computer Club and then Drama Club, and they're like, wait, what do I do with my columns now? Okay, so it's better to think when they only give you two categories, then it's good to think Computer Club, not Computer Club, and then over here on the side headings, Drama Club, not Drama Club. And then you start to use math to fill in the missing cells. So what was the question that they're asking? Okay, construct a two-way frequency table. Make a two-way relative frequency table and look for a possible association between the variables. So what does that mean, a two-way frequency table? So we've made a table with all of the breakdown of what classes or clubs rather these students are in. But anytime you see frequency table, they're actually looking for a percent. So you could make a whole other table. What I'm going to do is I'm just going to put the percent in that cell. So 15 or 15 out of the total 180. And that gives us 8.3%. Okay, then 65 out of 180. 36.1%. And we're just going to go all the way around. I have this table completed, so I'll go ahead and go a little bit faster. So 80 out of 180 is 44.4%. 95 out of 180, 52.8%. 5 out of 180 is 2.8%. 100 out of 180, 55.6%. 110 out of 180, 61.1%. 70 out of 180, 38.9%. And 180 over 180. So when you count up all the students that were surveyed, you have 100% of the students that were surveyed, right? So 180 over 180 is 100%. So what can we start to glean or figure out from this? So 8% are in both. 52% are in computer club only. I'm sorry, drama club only. Over here, 36% are in computer club only. 2.8% are in neither. So what can we start to figure out about this? It looks like most students are in at least one club. The next smallest group are students that have a very full schedule that are in both clubs. Now, which club would you say is more popular? The more students try to get involved with. So that would be drama club, right? And specifically of the students that are taking only one, there's a pretty big jump between students taking drama club only versus computer club only. And then we can start to look at this, okay? So 44% of the total students are taking computer club, and 61% of the students choose to take drama club. So that could start to help you make decisions if maybe you're looking at funding or looking at expanding space and resources for a certain club. You'd say, well, the numbers tell us that drama club is a little bit more popular, so we should put our resources in that direction. Okay. So let's see what the book's analysis of that was. So a student who is in drama club is probably not in computer club. A computer club member is not very likely to also be in drama club, but 90% of students are in one of the clubs. I would kind of disagree with that last sentence. I mean, 90% of the students are in exactly one. Looking back here. So this last sentence, I would maybe correct that one a little bit. It says 90% of the, saying but 90% of the students are in one clubs. That's kind of like saying, well, 90% of the students are taking advantage of the clubs. It's higher than that, right? There's only 2% of the students that are in neither. So it's really like 97% if you're going to your district manager or something. You would want to go to, and they were thinking of cutting funding for all of the clubs. you'd say you'd want to go with them with the highest number you could find, and surveying the community or the school, whatever these clubs are a part of, you would want to go and say that actually 97% of the students are interested in at least one club, right? Because it's only 2.8% that want nothing to do with any club at all. The other 97.2% are in one or both clubs. All right. So that's where it gets interesting. This starts to get directly involved in how funding happens in schools and governments and all kinds of things, and how you can start to make decisions based on the data. And you can go to your boss or parents or whoever you're trying to win a discussion with or persuade, and you can go with them with numbers to back up your idea or your proposal. So let's do this. I'm going to take a moment to check if there's any clarification that needs to be done, any questions that come up. I'll go through a couple of these examples here, and that would be a great coverage of wrapping up our two-way frequency tables. Okay. Okay. So let's get down with these last couple examples. So we're going to use this one table to make decisions about solving all 5 of these questions. So the table shows the votes in the last mayoral election and whether people voted for or against having concerts in the town park. Okay. So the table shows votes in the last mayoral election and whether people voted for or against concerts in the town park. All right. So how many voters voted against having concerts in the town park? So let me see if I can do another one of these. It worked out kind of cool the other day. Because I think I want to save this and not write in the book so I can make some quizzes out of it. All right, let's try something like that. So it's asking how many voted against having concerts in the town park. So what I would do is I would actually find all of the people in these 3 different categories that are in the against column, and I have to find the total number of people who voted against. So you can kind of watch what I'm calculating here. 165 plus 472 plus 423. So 1060 is going to go in this column. Okay, so that's the total number of people that voted against having concerts in the park. So for question 1, we're going to choose A. Okay, we'll save that. Hold on to that for a minute. Now, how about question 2? Which list correctly gives winners of the 2 votes? Which list correctly gives winners of the 2 votes. So we're saying Cogorno was 4, Quan against, Quan 4, and Leibowitz against. So which of those are accurate? So Cogorno did vote 4 because there was more. 578 is a bigger number than 165, if we're interpreting that question correctly. Quan against, so there was 472 Quans against, and 318 Quans for. So B, I would say, is true. Quan 4, I would say, is false, and because if they're saying that there's only 318 for with 472 against, I would say that no, it was the Quan voters chose to go against that choice. Leibowitz against, I would say that is also accurate, according to how they worded the question here, because 423 is so bigger than 217. So that gives us 2 having answers of A, B, and D. Now, question 3, what percentage of votes were recorded in the election were for Leibowitz for mayor? What percent of the votes recorded in the election were for Leibowitz for mayor? So we're going to have to do a little bit of math here. So we ultimately want to find the total because so what we need to do is find the total for Leibowitz and look at the total number of people altogether. So let's find the totals all the way around here. That's going to be helpful for us. So 578 it's 1113 going down here. If we add 1113 and 1060, we get 2173. So that would be how many total votes that were counted in this election. Now let's go across. Okay, so how this is broken down again is that there was 2 things happening here. There was these 3 mayors running to win, and it also broke down. So the city was trying to figure out who their next mayor is going to be, and for or against putting money towards the new park. So let's now go across, and so this is that there's a total of 1,113 for paying for a new park, and 1,060 against paying for a new park. Now let's look at who won the mayoral election, right? So if we could say 4-1 to get the new park, 4-1. Now let's see who won the election. So 578 plus, because that whole row voted for Cogorno. It's just that some were for the park, some were against. So 743 voted for Cogorno. Let's do Quan, 318 plus 472. That's 790. And Leibowitz now, 217 plus 423. I give us 640. So just looking at this, who won the election, who had the most votes? Cogorno had a total of 743. Kwan had a total of 790. And Leibowitz had a total of 640. So I would say that Kwan was the winner, right? But that wasn't what it was asking. It was asking for what percent of the votes recorded in the election were for Leibowitz. So maybe Leibowitz was going to say, well, you know what, did I lose by a lot or a little? What percentage of the votes did I get? So how we would do that is we would do 640 divided by the total number of voters in this election. Oh, sorry about the glare. So 640 over 2173. Let's get a decimal. So that would be 0.295 or 29.5%. So looking down at the options, B is 29.5%. There's the calculation again. 29.5%. That was the percentage of the voters that wanted Leibowitz. Okay, almost done. So which expression gives the ratio of voters who voted for Kwan, who also voted for concerts in the town park? Oh, sorry, it wasn't for a new park, it was for allowing concerts in the park. Okay, so which expression gives the ratio of voters who voted for Kwan, who also won concerts in the park? So we look back up here and we look at this intersection of folks that wanted concerts in the parks. We look at 4, and let's look at the horizontal cross. We're looking at Kwan. So where do those intersect? They intersect over this middle left cell of 318. So that's going to be the top. So that doesn't help us too much so far because all of them have a numerator of 318. Okay, at least we've known that we picked the right numerator. So we want to see the total number of people, okay? So 472, that's inaccurate. That doesn't really give us any type of information. It's how many for over, how many against. So that would be, I suppose that would be if the question we're asking what percentage of Kwan voters wanted concerts in the park. How about 318? 318 over 318 plus 472. Oh, I'm sorry. That would be how many? That would be the total or the percent of people of Kwan voters that wanted concerts in the park. That would be over the total. 318 over 472 would be the ratio of for versus against for Kwan. Let's look at, that's also not going to be the right answer because we want the total number of voters, right? It gives a ratio of voters who voted for Kwan who also voted for concerts in the park. So let's go ahead and I'm going to let you think about that for a minute. Which of these 4 is going to give us that expression? Let's put this back here. I want you to think about that for a minute. Maybe I'll put it to the side since it's covering up that question. Okay, so How about 578 over 217? What does that tell us? So we're getting closer, but this is again giving not the information we're looking for, because we want a part out of a total, and we're going to get that by looking at all of the 4s. So we want to look at the 578 plus the 318 plus the 217, and that's going to give us the percentage of Quan voters that voted for Quan of the voters that wanted it in the park. Okay, so what we could see here then is, now we know that Quan won the election, but if we were saying, which voters were the most excited about, if the town's goal was to have concerts in the park, then it was the Cogorno voters that were the biggest contributor to those that did want to have the concerts in the park. But coming back to answer this question, we'd be looking at the part over the total of the 4 is going to answer voters who voted for Quan, who also wanted concerts in the town park. Okay, number 5. So what percent of voters who voted for concerts in the park also voted for Cogorno? So of the people that wanted concerts in the park also voted for Mr. C. So I'll let that give you a second to think about that one. We'll do that again together in just a moment. Okay, did you give that one some thought? So what percent of voters who voted for concerts in the park also voted for Cogorno? So we need to look at the total number that voted for, and that is going to be the denominator for our calculation, and the numerator is going to be what was the segment that, of the ones that wanted the concerts in the park, what portion of those were Cogorno voters. Okay, so you could say that 51.9%, so I did the 578 over the 1113, and we could say 51.9% of the 4 voters were Cogorno supporters as well. So you could say that maybe Cogorno supporters are the park party animals of this town, right? Because it was a majority, 51.9%, that wanted the concerts in the park that were Cogorno supporters. So that would be C for number 5 there. And that would be our solutions, right? So I'm going to leave this page up here. I'll put these totals that we worked on. So I'll leave those up for one more observation if you need to pause the video there after this is done. Oh, and you know what? We made a mistake. I read this incorrectly before. I thought they were asking us which of given congruent voters, how many voted for or against that decision. So what they're actually asking is which correctly gives the winners of the two votes. And that was actually back at, I don't know why I read it the other way before. So it was actually 4 that won, right? People that were 4. And then Quan was the winner. So I gave the inverse of what they were looking for. Right, so as Quan was the winner of the election, and Concerts in the Park was the winner. So I gave you the inverse solution there. Sorry about that. And that is it. I'll check one more time for the questions. Go ahead and put those in the comments. And that will wrap up our summer review. How about that? So school is right around the corner here. I'll post the quiz for this on Sunday, and we'll head right into the back to school preparation. Okay, if you have any questions about how that works, go ahead and shoot me a message, either in the messenger or in the discussion boxes, and can help you out with that. All right, thank you very much, everyone. I'll go ahead and wrap up, and I will see you on Sunday is when we plan to go over the solutions for the quiz for this past week.